Hello everyone, welcome to LeetCode. So in this video, we will see the question that is spiral matrix. It is question number 54 on the LeetCode platform, and it is a medium level question, and it has been also asked in interviews like technical interviews like Amazon, Facebook, Google, etc. So given a matrix of m into n elements, and m denotes rows and n denotes columns, return the all elements of the matrix in spiral order. So this is the input that we're given or the example. So in this we are given input as a 2D array or a matrix. We have to return it as a 1D array or a array vector, you can say. So let's see the example. So I will explain the example in here. So it is told that we are given a 2D matrix and we have to traverse it in a spiral order and add it to our result or output vector and print it. So let's see how we can do that. So you can see I have made this as a 2D array, so a 2D matrix. You can see this is a 2D matrix. For traversing spirally, actually spiral order is like this. You can see spiral order is like this, and it is a clockwise, so we are moving in this direction. So for doing that, so we will have to start from this first element. So we will traverse till here. So 1 2 3 4, you can see 1 2 3 4, and then from 4 we will go to 12. So we have to form a spiral order. You can see this is a spiral order. So then from 12 to 9, sorry for that, so 12 to 9. So you can see now we will go till 5 because we have printed 1, so 1 is actually complete. So now from 5 we have to go till this. So you can see we have got our traversal order. So our output should be 1 2 3 4, 8 12 11 10 9 and 5 6 7. So you can see it is correct. So this is our output that we require, or the spiral traversal of the matrix. So first of all, for doing this we will have to use some like a variable to change the directions. If you see in this example, we are not moving in one direction only. So we are going, sometimes we are going to left to right, then we are going from top to bottom or right to left, and similarly upwards. So for this we will have to maintain a variable to check the direction. So for that we will have to use a flag. So I will explain you the algorithm, but I am just making the basics clear first of all. So you can say, you know that now you will have to use a flag or a direction variable to check in which direction you are moving, because we have to move in 4 directions. So we have to form a spiral order. So for that we have to move in 4 directions, that is will be left, right and top and bottom. So let's see now. So for doing that we will have to like use 4 flags, 4 pointers. So to point to the first row and the last row and the first column and the last column, because we have to like squeeze them and print the elements using these pointers. So there will be condition, like if you are printing from like we have to print from this 1 to 4. So for that our flag will be like we are moving to the right side. So our flag should be moving to the right. So it should be like giving the right direction, and then we have to print the elements between the left pointer and the right pointer, and for the first row. So let's see, I will explain you now. So in this I have written the pseudocode actually. So I am actually using the mouse to write this, so it will be a bit difficult for you to understand. So let me so here you can see I have sorry for this. So where is the highlighter actually? So you can understand like this now. So maybe it will be better. Okay, so it's actually working. So yeah, so now if you see, so we have to move in 4 directions. As I told you, we have to use 4 pointers. So first pointer will be pointing to the first row and the last row, that is the first and the last row. It will be top and down pointer. Then we have to use a left and the right, so we have to point also to the first column and the last column. So for these we are using the 4 pointers. So now if you see, we have 4 directions. As I told you, we will use a direction or a flag variable. So in this example you can see I have initialized a direction flag variable, and these are the pointers. So top pointer will be pointing to the 0th row, and the bottom pointer or the down pointer will point to the n-1 row, and the left similarly to the 0th column, and r will be m-1, the column, last column. You can see last column -1, that will be this index. So then we will initialize our direction variable. So our direction variable will have values, like you can change the values actually, but I am taking the values as, for right we will require the value as 1, and for right we will require value as 0. Okay, the value for right will be 0, and for down, actually let me write it only. So down it will be 1, for left it will be 2, and for top it will be 3. If you see, these are the values that our direction flag will have. If we have value as 0, that means we are moving from left to right. That is our first step. Then our second step will be top to bottom, then this right to left, then upwards, then again left to right, then again bottom, left right to left, then top. So this is how we are going to use our pointers. So for this I have written like I have give it the color, so you can see it is yellow color. So this is the code or the pseudocode for the yellow color or the moving from left to right. And this is similarly for the down, when we have to move down, this condition is for the moving down, and this condition is for moving from right to left, and this is for moving to top. So let's see. So I hope I have cleared the basic requirements or the things that you need to like use in this program. So now if you see, first we will start. So our condition will be while top is less than down and the left is less than right. So we will run a while loop while our top is less than down and left is less than right. If you see, now top should never like bypass or like get greater than the down, because we have to print only till the matrix and keep them inside the bounds of the matrix. So now let's see. So when we start, our direction is initially 0. Our direction variable is initially 0. So that means we are printing from left to right. We have to traverse this row. If you see, we have to traverse this row, and for traversing this row, this condition will be true. Okay, this condition will be true as direction is 0, and for this we have to use a for loop to print this. And what will be our bounds? So our starting position will be left. You can see the starting column and the ending column. So our starting position or this pointer will start from left to right. It will move from left to right. Our for loop, you can see, is from left to right, and we are only traversing the first row. So our this row is constant, so that will be t, the top. So our top row is for top row we are traversing all the elements or all the columns in that row. You can see we are running the loop from left to right. We are running the loop from left to right and adding the result and adding the like these elements in the result our vector or the output array, and we are adding the elements as such. You can see matrix of t. T is the first top or first row that we are traversing, and I will be changing columns, that are the elements that we are traversing. So in this way we will end up adding for this loop we will end up adding elements as 1, 2, 3 and 4. So you can see, okay, 1, 2, 3 and 4. Let me add the spaces. So you can see these are the elements that we add after this condition. So now after every this loop, you can see we will have to increment our top pointer, because if our top pointer stays here, we will keep end up traversing this row only. So we have traversed this row, so we have to increment our top pointer. So top pointer will come here. Now it will not point to this position or the starting position, but our right and left pointer will stay as it is, because we have to like traverse from right to left again and from right to bottom also. So we don't need to like change this left and right variables now, but our top will point to this row now. So let's see. Now after this, these are all if else if conditions. So you can see all the conditions after this will be skipped, and at the end we will how we can change the direction. So actually our directions are consecutive, you can see, so we will add simply 1 to them. But if you think if we like run this for 4 times, then we will end up like getting it out of the bound, so our direction will become more than 4. So for that we have to use a modulus operation. So if you see our direction becomes 4 or 5 modulus 4, so it will like make it or map it to the like it will be mapping it to the our output, so its modulus will be actually 0. So that's how we are keeping it in bound using the modulus operation. If you know we for using the circular arrays or implementing them, you have to do this. So direction plus 1, because we have to change the direction from 0 to 1, and if it gets out of the bound, we have to keep the modulus of 4, so it stays between 0 to 3. So this is what we have to do, and our first iteration is over. Now again our direction is 1. We come to this loop, so it is not true, this condition is not true. Direction is equal to 1, so that means we have to move from top to bottom. You can see down. So now for moving that from top to bottom, you can see we have printed elements. This 4 is printed, so we don't have to add it to our output. So our top as it is incremented. So now if you see, we have to like traverse this rows. So traversing this row, our row will change. So we have to write a condition like for loop from top to bottom. It will run, you can see, from top to bottom, but the row or the column will be the last column only. That will be R, the right pointer or the rightmost column. So you can see we have to print from top to bottom or the top to down for the last column. So we will print these elements or add these elements into our result. So you can see our rows are changing, so it will be I from T to D, and our column is constant. It is the last column that we are adding. So we will end up adding more elements into this, like 8, 12 and 16. I hope I am able to explain you the stuff that like you have to, how we are going to this and working and using it actually. So if you see, our top will be now here only, because our top will not change. We have traversed for the row, the row which we keep static, or the column that we keep static. We have to increment that thing. So now our R will be decremented because we have printed all the elements from 4 to 16, this line. So this column should not be printed again, so we have to decrement our R. So R will be decremented at the end. You can see here we incremented our this top. So now our R will be actually, if you see, this R will be decremented. So let me write the R here, so it will be easy to understand. So actually I will have to write it only. So R. So if you see now our R is pointing to this column. So now our again all the conditions after that will be skipped. Now our direction will be incremented, so it will be +1, so it will become 2, and modulus 4 it will be a 2 only. So now for this again we enter into this condition. All our these conditions are satisfied. You can see top is less than D, and yes, L is less than R. So now we will skip this condition, and now we'll end up using this condition. If you see direction is 2, that means we have to move from right to left. If you see left, so we have to move from right to left. So for doing that, you know that we cannot start from the last column. We have printed the 6 or added it to our output. So now we have to add these elements 15 to 13. So you can think of now how we have to like use a for loop. So if you see, we have to print the elements from 15 to 3. So for doing that, we have to simply start the loop from R to L. You can see we have to loop write the for loop condition from R to L while I is equal to R and greater than L. So then greater than equal to L, then we will print the elements in the bottom row or the down pointer. So now our row is constant, so our row will stay as it is. You can see we will run a loop from I will run from R to L. It will be running from this index, that is from 2 to 0, and it will be actually equal to L. So it will run till this L. It will not end up before this L. So it will go till L. Then we have to add it over output. So our matrix of D, because our row is constant now, the bottom row, we are printing the bottom row starting from this second last index. It will be I. So I is changing. So columns are changing. The row is constant. So I hope you got how we are doing this. So now let's see what will be the next step. So as you know, we have traversed our all this ending row. So now our D will be decremented, if I'm not wrong. So our D will be decremented. Yes, you can see D is decremented because we have traversed all this row. So you can see these are traversed. Actually, let me mark them as this. So these are traversed. So we are left with these values. So for doing this, we have to make like this. So we have to traverse them like that. So now this direction will be again incremented. It will become 3. So now we have to move top. So yes, it is true. You can see we have to print from 13 to 5. So now for doing that, we will end up skipping all these conditions, and in this condition it will be true. Direction flag is equal to 3. So that means we have to move to top. You can see top, and it is also of same color, orange. So now let's see. So for printing the elements till top, we have to do one thing. Let me just delete it also. So now if you see, our down is here and our left is here, right is at this point, and we have to print elements from 9 to 5. So that means we have to run a loop from we have to print the elements in the column 1 or the L column, and we have to traverse from D to T. You can see we are left with 9 and 5, and we have decremented T and incremented T and decremented D. So now for that we have to run a loop from for I is equal to D, it will run till it is not equal to T. So you can see for I is equal to D and it is running till T, and we have to add the elements in this our row will change. In this column column will stay same, so it will be a matrix of I and L. Our column is same. You can see for first column we are printing, so we will end up adding values as such. So 9 and 5. So if you see, so after 6 we forgot to add the value, so it will be 15, 14 and actually 13. So now we will add values as 9 and 5 after this condition. So now again we have like traversed this all the whole first column, so it will be cancelled. So now our L will be incremented and it will come to this column. So you can see, yeah, L is incrementing. So now let's see. So our direction flag will be incremented. So it will be incremented. So it will become 4. 4 modulus 4 will be 0. So actually I forgot to tell you. I think I told wrong. I told 5 modulus 4 as 0, but it was actually 1. Sorry for that mistake. So 4 modulus 4 will be 0. So now we will map to the 0th index again. Direction will become 0. That means we have to move from left to right. For doing that, we will end up going into this condition. So it will be direction equal to 0. So yes, it is true. 4 modulus 4 is 0. So now we have to print from left to right for this top row. So you can see we have to print from left to right for this top row. I hope you have understood it and how will it work recursively. So we will add these values, so 6 and 7. Now our top will be incremented because we have like traversed all the elements here. So our top will be it is not there. So L is here and our R is here and our top is incremented. So you can see, so in this way, so we will our condition you can see here is top is while top is not while top is less than equal to D. So that means they will end up, so top is incremented, so it will come here. So you can do it will come here in this condition. So it the loop will run as I was telling you, it is less than equal to, so it is equal to, so the loop is the condition is true, so loop will run. Now we will print the elements from this 7 to 11 we have to print, but 7 we have printed, so we have to don't have to print that, and we have to run a loop from top to bottom. So you can see we have to run a loop from top to bottom. I forgot to tell you the step, but you know that we have to increment the direction, then again we will end up in this condition. These conditions are actually iterative. You can see we will first use this, then this. So it will not like we use this, then we skip this and use this. So it will be not like that. So they are iterative. So now we will print for run the loop from I is equal to top till down. So it will end up printing this element or adding this element into our ending or the result array. So it will be 11, and then we will add 10 as it will decrement the right pointer because we have printed it here. You can see our right pointer is decremented in this R minus. So this will be the basic algorithm that will be used. So let's I will show you the code now. Let's see the code. So I will also share the code in the description. Actually the code is similar to this pseudocode, as I told you, it is actually similar. So you can see actually if you try to use all the code, this code, and you don't check the base condition that if matrix is empty, so you don't check this condition, so it will not pass on LeetCode. I also did this mistake. You can see I tried to submit but it didn't got accepted. I forgot to add the base condition. If matrix is empty, you simply return the output like empty array or the vector. So let's see. So first of all we like get the size of the rows and the columns, and we make output array, and this is our direction variable that we'll be using, and top, as I told you, top, bottom, left and right, we will like initialize them. Then we will run a loop while top is less than bottom or the down, and left is less than right. So as I told you, top is this first row, the down is the bottom row, and left is the first column and the right is the second column. So actually we are using the four pointers, and first of all our direction will be 0. So that means we have to move from left to right. Direction 0, that means left to right, we are going to the right direction. So for that I hope you like got how this condition came and all that stuff. So I explained you all that. So let's see. So else if our direction is 1, that means we have to go down. Our direction is 2, we have to go to the left side, and then our direction is right, so we have to go to the direction is 3, so we have to go to the top. So this is how our loop is running, and while loop, and these are the conditions. And after every you don't forget to increment the top and decrement right and all these conditions. As I told you, if we have traversed one row, so we have to increment it to the next row, because we will end up printing the same row again and again. So you need to keep that in mind. So again after that we have to change the direction. So this is also the important step, and you have to do the modulus 4, otherwise it will not work properly. So then after that we will end up adding all the elements in the result array or the vector, then we can simply return it. So let's submit this solution. So let's see. So yes, you can see it got submitted, and it took like it is faster than, you can see, 100% of solutions, and it took less memory than, you can see that. So I hope you got this code and how to use this, and a small trick like how we can use this pointer and imagine this. So you can like try it on a paper with your paper and pen. You can try it yourself and try to like work in on a bigger example or a like smaller example. So thank you for watching, guys. Thank you.